Hey, what's up, Math 8? This is Mr. Bainey, and today's lesson is 8.5, the last lesson of this module, solving special systems. Our essential question is, how do you solve systems with no solution or infinitely many solutions? So this is sort of tied to the very last lesson of module 7, if you remember, when we get no solution, infinitely many solutions, or one solution. When we solve a system, what's been happening with all the problems that we've been solving, we get a point, right? Remember, we get an x value and a y value. And if you recall, all the way in 8.1, we are graphing. So think about when we graphed, what the answer looked like and where to find it. It is where the two lines intersect. So when two lines intersect, that intersection point, right, the point in the overlap, is your solution. So we're going to look at what happens when the two lines don't intersect or they intersect in some special way. So if we look at this explore activity, we have some sort of difficult equations to graph, but I'm gonna help you with it. We've got x plus y. I'm gonna write it on these lines here just so we have some space. Equals 7. This is not in the y equals mx plus b form. So I'm going to write it like that, y equals mx plus b. All this means is I want to get the y by itself. You see it says y equals. Here I have x plus y equals. So what I want to do is I want to subtract the x, and I get y equals negative x plus 7. So when I graph this line over here, I get the y-intercept is 7. So if you look on the graph, it's where I put that red dot. And the slope is negative 1 over 1. So down 1 over 1. And you can see that my line is this one right here. Okay, the one that has a negative slope, it's going down through the 7 y-intercept. Okay, so that's that first line. The second equation, I got 2x plus 2y equals 6. And if I try to get y by itself here, then what I want to do is subtract 2x. And I get 2y equals negative 2x plus 6. Then divide everything by 2 because I got a 2y. I just want a y. So divide everything by 2. And I get y equals negative 1x plus 3. Okay, so I divide everything by 2. So that means y-intercept at 3, and I'm going to go down 1 and over 1. And so my line is this one right here. So now you can begin to think, okay, I graph both of these lines. Do both of these lines intersect? And if so, where? So you might see that they're actually not going to intersect. They have the same slope, right? And go down 1 over 1. The other line has down 1 over 1. So we can argue that if I go on forever, right? Remember we have these arrows, means it keeps going. Up here it keeps going. We can use the slope to argue that this thing is never going to intersect. So what does that mean? That means, sorry, that there is no solution. So the question here is saying, is there a point of intersection? Explain. So I am not actually going to write down the explanation, but the answer is no, there's no point of intersection. Okay, they have the same slope. You can use that as your explanation, but they're not going to intersect, so there is no solution. There's no answer to this. Okay, so if we take a look at the next one, part B, The 2x plus 2y equals 6 and x plus y equals 3. Instead of me actually graphing these, I'm just going to show you which ones they actually are. And then we're going to look at what the answer is. Is there a point of intersection? And does it have a solution? So we got 2x plus 2y equals 6 is, I'm going to do this in a different color here. 2x plus 2y equals 6 is, sorry, it is this pink line, actually. And x plus y equals 3 is, you know what? It's actually the same exact line. It's this, I'm going to do it in purple. X plus y equals 3 is the same exact line. So what does this mean? If I were to ask you, where do these two lines intersect? Where do they touch? Well, they actually intersect everywhere. They intersect there, all these red points. Well, actually, I'll just use my cursor here. They intersect there, right? All these places that I have my cursor on, it's intersecting, it's touching, it's overlapping. So how many solutions or how many times does this thing intersect? It intersects an infinite amount of times. So we have an infinite amount of solutions. So when we're graphing, if they never touch, no solution. If they always touch, if they're overlapping, infinite solutions. Okay, and you can start to think about, well, we're used to getting just one solution where they intersect once. Is there anything else that could they intersect twice? Could they intersect 3 times? What would that look like? Okay, some things to think about. But this is how it's going to look like when we're graphing. If you go all the way to page 263, we're going to look at an algebraic way, or the other two methods, right? The substitution and the elimination. If you want to see substitution in action, there's actually an example on the previous page, page 262, that you can take a look at. We're going to focus primarily on the elimination method. So if you go to the bottom of page 263, we're going to try to cram this in here. They're not too generous with the space, but number 6. We got 4x minus 6y equals 9 and negative 2x plus 3y equals 4. So I'm going to want to eliminate the x's. I'm just going to choose that one. You could choose the y's if you want. And since I want to eliminate the x's, my LCM of those two is 4. So I want to make both of them a 4x. And negative 4x is also fine. So I need to multiply this equation by 2 to make that a 4x. So I'm going to copy my first equation, 4x minus 6y equals 9. Didn't do anything at all to the first equation. When I multiply 2 times everything, I get negative 4x plus 6y equals 8. Okay, we don't need a lot of space here because all we need to find out is, are we going to get an answer, or is something weird going to happen, right? Are we going to end up with some special case here? So how do I make my 0 with the x? Well, I just need to add them because one's positive, one's negative. So I just add them together. So add these and then add these. I get 0 for that. Let's do a different color. Sorry, that's a 0. Negative 6y plus positive 6y. Isn't that's also 0. And then that equals 9 plus 8, which is 17. So, well, I don't have anything left over on that left side with all those zeros, so it's just 0. And I get 0 equals 17. Now, if you remember the last lesson of Module 7, when we get a false statement like this, right, 0 does not equal 17, sorry. This means there is no solution. There is no point where these two lines are going to intersect if I graph it. Okay, there we go. I'm going to start off number 7 for you, and then you'll finish it off. I will ask you to pause it once I give you the cue to do that, and you can check your answer shortly after. So, number 7, I'm going to choose to eliminate the x's again. So I'm going to multiply the first equation by 2. Oops, 2, because I want to make the x into a 2x. Okay, so that's my hint to you. See if you can go and finish this off, figure out how many solutions you have. Please pause it right now, and the solution will show up in about 5 seconds. As you can see with my work, I multiplied the 2 with the first equation and got 2x plus 4y equals 12. Copied the second equation. I subtracted straight down, and I eventually got to y equals -2. So I don't need to go any further for this to tell me that I'm going to be able to plug in -2 into here and then figure out what x is. So that tells me I get one solution. So I don't even have to know what x is. I know that I'm going to get one solution because I have a y. So you're totally fine with just stopping where I stopped. And you don't need to go any further. In fact, you can probably even stop right here. So I don't mind if you just do a little bit less work than me in order to realize that. Okay, number 8. Go ahead and pause that as well, and then give that a try. Solution will be showing up here in several seconds. Okay, here's what I have after the first step of multiplying 4 with the second equation. I chose to focus on the y's to eliminate, so I wanted to make both of them into an 8y. So I ended up with the equations below that you see. I need to add, because I have a negative 8y and a positive 8y. So that's what I wanted to make a 0 with. So let's add everything else. So I got positive 12x plus negative 12x. Well, that's a 0. And I got negative 4 plus positive 4. That is also a 0. And looks like we don't have anything left over. So I got 0 on the left side equals a 0 on the right side. Now this is a true statement. So if you remember what this means, it is infinite or infinitely many solutions or infinitely many answers. So if you remember from the first page of this lesson, it's when the two lines overlap each other. They intersect everywhere. Both of these lines, if both these equations, if you were to graph them, are the same exact line. Okay, and that's going to do it for this lesson. Thank you so much for watching. Hope it helped. Have a great day.